requested to give a short tutorial on lowest common multiple, LCM, also known as least common multiple, or even least common divisor. Okay, so we'll go by initially I'll show you the traditional and very straightforward way to find it, and then I'll show you a shortcut. So if someone asked you to find the lowest common multiple of 3 and 4, all they're asking you to do is find the multiples of 4, which are the first one that coincides with a multiple of 3. So the first one, for either one of them, that is the same as the multiple of the other. And two numbers may have multiple common multiples, so many common multiples, but we want to find the smallest one, the least one, the lowest one. Okay, so what we do is then first we go to the times table, 4 times table. We write out the multiples. So we start for 4. It is 4, what else? 8, 12, 16, right? 20. Okay? And for 3, it is 3, 6, 9, 12, 15, right? We can keep writing, but this is just to show for low numbers, like 4 and 3, they're fairly low numbers. So it's likely that the LCM, the lowest common multiple, will occur quite early. So we don't have to write too many. You can see that the 12 and the 12 here, they are the first ones that appear in both lists. It's the first number that appears in both lists. So it's the least common multiple. Now, so that's the answer to that question. What's the lowest common multiple of 4 and 3? It's 12. Like I said before, there are other multiples. If you kept on doing the 3 times table and the 4 times table, soon you'll hit another common multiple. But this is the lowest one. That's what we're interested in here. Let's go to another example. 9 and 6. Okay, let's go into the 9 times table. So it's just 9, 18, 9 3s are 27, 9 4s are 36. Yes? Okay, let's go to the 6 times table. 6 1s are 6, 6 2s are 12, 6 3s are 18, 6 4s are 24. Okay, let's just stop and check. Can you see a number that's occurring in both of the lists? Yes, 18. And that is your answer. So here the answer is 12. Here the answer is 18. Let's look at a third example so you are no doubt. 8 and 5. Okay, don't worry, Batman. All right. 8 is 8 times 1 is 8. 8 times 2 is 16. 8 3s are 24. 8 4s are 32. 8 5s are 40. Okay, let's start on the one for 5. 5 1s are 5. 5 2s are 10. 5 3s are 15. 5 4s are 20. 5 5s 25. 5 6 are 30. 35. 40. Okay, I'm running out of space there. Maybe I should. It's not that visible there. Let's 30, 35, and I'll write the 40 down here. if you look at both lists, anything appearing in both lists, the earliest one you'll find is the 40. Right? So that is the answer. 40 is the answer for these two numbers. These two numbers and these two numbers, the answers are written up here. Now, it seems time consuming to write all of these out, especially if these numbers are big numbers, because then you're going into what's a 13 times table. I didn't learn that. Gosh, it would take me all day to write all of these things out. Fair enough, and that's true. We want to find you a really quick way to get to the answer. So that way is a way you can get to the answer, but you want to cut down time. Right? One of my earlier videos was not only looking at equivalent fractions, but reducing fractions to their lowest terms. So that is going to be part of the hack of how we get to the lowest common multiple as quickly as we can. First example to show how it goes is 8 and 12. So you have these two numbers. First thing you do, you put it in terms of a fraction. So just whack one on top of the other. Now you're going to reduce this to its lowest terms. And if you remember, what are factors of 8? Well, 1 and 8, 2 and 4. Okay. Let's go with 2 and 4. Remember, you can always change something later. You can always change your mind if something doesn't work out. But first we find something that's staring us in the face, write it down and see if it works out. Now, once we've broken down the lower number, we go for the bigger number now, using one of these. Now, I could go with using 2, and we could do 2 times 6. Yes. What about we go after the 4? 4 times 3. Yes. 4 times 3 is 12. I've got a 4 on the top and on the bottom, so they can cancel out. So what I'm left with, of course, is 2 over 3. So that is this fraction in its lowest terms. Now you're going to multiply the numerator here with the denominator here. So 8 times 3, 8 threes are 24. You'll notice if you multiply the denominator here and the numerator up here, 12 times 2, what do you get? 24. You'll get this exact number. And guess what? That is the LCM. That is the least common multiple of these two numbers here. Let's go with another one. 20 and 50. Now, 20 and 50, let's write it here in terms of a fraction. What did I show you before? If you have zeros on the top and on the bottom, for every 0 on the top, you can cancel it out on the bottom. Because all that means is 2 times 10 and 5 times 10. So the 10s cancel out. But shortcut is cancel out zeros. 2 over 5, right? Can you break the 5 down any further? No. 5 is a prime number. I'll explain later in case you don't know. And so is 2. So really you've gone as low as you can go. 20 times 5. 20 times 5 is 20, 40, 60, 80, 100. Yes? So that was multiplying this way. What about multiplying this way? 50 times 2. What does that get you? Exactly the same. Guess what? That's your lowest common multiple. Okay. So these are numbers where you can break them down further, right? So the numbers on the top and the number on the bottom, they are not prime numbers. So you have to reduce them further. Now, in case you don't know what a prime number is, and that's a separate topic on its own, but prime numbers are two things. They are numbers greater than 1. So it must be a number greater than 1. So it can't be 1. Can't be 0, can't be a negative number. And the second quality is it has only 2 factors, 1 and itself. So when you break it down, it's only 1 in itself. Like say, for example, 2. It's greater than 1, yes? Can you break 2 down further? Not really. It's just 2 times 1, nothing else. That's if you're multiplying 2 whole numbers, right? So 2 times 1. That's as far down as you can go. What about, so you know 2 is a prime number. Okay. So as soon as you get any fraction where 2 is either on the top or on the bottom, it's hit a prime number. All right. What about 3? Is 3 a prime number? Now the factors are 1 and 3, but can you multiply any 2 other numbers to get 3? No, it's just 1 times 3. So 3 is also a prime number. What about let's say, for example, 7. Okay, 7. 7 times 1 is 7. Are there any other 2 numbers that you multiply to make 7? No, you can't, because 7 is a prime number. What about 4? Is 4 a prime number? Well, 4 is not a prime number because 4 is not only 1 times 4, but it's also 2 times 2. So as soon as you find any other 2 numbers that multiply to make the number that you're trying to find out whether or not it's a prime number, if one of those numbers is not 1 or itself, then of course it's not a prime number because you can multiply another 2 sets of numbers. Okay, so what was the importance of my explaining that? Now, when you get 2 numbers, one of which is a prime number, then it reduces the work that you have to do. Say, for example, if we use, like, say, 3. If 3 was one of the numbers that I used, and if I use, say, a non-prime number, like, say, 12, okay, so 3 over 12, this can only be 1 times 3, right? Because it's a prime number. So you know immediately this 3 will be used down here because 3 times 4 is 12, okay? 3's cancel out and you're left with 1 over 4. So when one of them is a prime number, you only have one option, 1 times 3. So already if the bottom is not a multiple of 3, then that's where you end right there. So in this case, it was a multiple of 3, so you could break it down further. Let's choose another example. Sorry, if I complete this to the end of the process, so 3 over 12, multiply 3 times the denominator here is equal to 12. 12 times 1 is equal to 12, so 12 is a number, the lowest common multiple. So you see some of these shortcuts when you see one of either of these 2 numbers is a prime number. Then you'll have these situations. So say, for example, we choose two prime numbers. Say 9 is not, sorry, 11 and 7. These are both prime numbers. Now what happens when you have both prime numbers is you can't reduce it any further, because this will be, if you've made it a fraction, then this will be 1 times 11, and here will be 1 times 7. You can't do anything. You're still stuck with 11 over 7. So in that case, when you have two prime numbers, what you will do is you will just multiply that multiplied by this one. So 11 multiplied by 7. And the answer there would be 11 sevens, 77. So see what happened when only one of the numbers was a prime number, and here when both numbers were prime numbers. When both numbers are prime numbers, you just multiply them by each other, and you will get the least common multiple. And this, what happened in this case is one of the numbers themselves became, so the greater of the two numbers became the least common multiple. Let's try another two numbers where one is a prime number and one is not a prime number, but also is not a multiple of 3. See what happens then. So let's say we stick with 7, and now we choose a number that is not a prime number, but is not a multiple of 7. Let's say, for example, 12. 12 is not a multiple of 7, but also this is not a prime number, because 12 is 1 times 12 and also 3 times 4. So let's see what happens if we do what we did up there. 7, which is the prime number, over 12, which is not the prime number. It's 1 times 7. Yeah, can't do anything more because it's a prime number. And 12. 12, you can't break it down further. It's just, 1 times 12, or 1 times 3 times 4, or 1 times 2 times 6. But all of those, none of those are 7. So you know what happens then. It's exactly what we did in this case. You multiply one number by the other. And 7 times 12 is 84. So when one of the numbers is a prime number and the other number is a multiple of that prime number, then the answer will be the multiple of the prime number. But if both numbers are prime numbers, or one number is a prime, as in this case, both numbers were prime numbers, so you just multiply to find the lowest common multiple. One number is a prime number, the other number is not a prime number, but it's also not a multiple of the prime number. Then again, just like you do when you have two prime numbers, you just multiply one with the other, and that would be your lowest common multiple. If you would like to work through a few more examples, I can quickly put them up now. Let's say 6 and 5. Okay, how would we attack that? One of these two numbers a prime number? Yes, 5 is a prime number. Is 6 a multiple of 5? Like, does 6 appear in the 5 times table? No. So one's a prime number and the other number is not a multiple, then you know what happens then? You just do 6 times 5 and the answer will be 30. And that is the lowest common multiple. So that was a prime. And this one is not multiple of the other number, which, as I said before, just means it doesn't appear in the 5 times table. Now that, I hope you can still read that. Right, okay. So that was the first one. Let's go with another one. Let's choose slightly bigger numbers, okay? 13. And say 25. Okay. Now, we know, when we look at 25, we know 5 5s are 25. So immediately we know that's not a prime number, because 1 times 25 is 25, but also there are other ways to get to 25, and that's 5 times 5. So not a prime number. Then we have 13. Is 13 1 times 13? Yes. But is there any other way to get to 13? 2 other numbers you can multiply to get 13? Does the number 13 appear anywhere else in the 13 in any of the other in the times table from 1 to 12? Does 13 appear anywhere there? No, because it is a prime number. So we know this is prime, and this is this 25 a multiple of 13? I mean, 13 times 2 or 3 gets you to 25? No, 13 times 2 is 26. So we know 25 is not a multiple. And what's the short way of doing it? 13 times 25. What did I say? Not a multiple of the other. $13 times 25. Well, I'll have to do it the long way, yeah? Three times 5, 15. Carry 1. 2 times 3, 6 plus 1, 75. 0. 1 times 5 is 5. 1 times 2 is 2. 5 down here because we're adding these two. That and that is 12. Carry 1. 3. 325. So 325 is your lowest common multiple. Let's go with the third one. Sorry, I'll just rub out. It's getting a bit messy looking. Right? If we pick another 2 numbers, we've been dealing with too many primes. Let's deal with some other non-prime numbers. Let's say 16 and another non-prime number. Let's say 9. Both of them are not, there are other ways to get to them other than 1 in itself, right? Okay, so what does this mean? You'll have to put it in terms of a fraction, and then you have to break it down. So 16 is what? 2 times 8. What else can it be? Can it be anything else? So it's 2 times 8. It can also be 1 times 16. And this 8 can be, 2 times 4, and 4, of course, you can break it down further into another 2 times 2. Okay, so those are options. What about 9? 1 times 9 and 3 times 3. Can you see any way to simplify that? It seems we can't simplify these any further. So what does that mean? That really appears to be the simplest form of that fraction, which means that you multiply the 2. So we've investigated, no go. Next step is just 16. So here you can't simplify. You can't cancel out anything on the bottom with anything on the top. So you just 16 times 9. 16 times 9 is 9, 6 are 54. 9 ones are 9 plus 5 is 14. 144. Yes? Okay. So looks like the answer to this question is 144, and that is your lowest common multiple. I hope you understand it better now. If you found the video useful, like and subscribe for notifications.